Okay, so today we're going to be using Ansys CFX to simulate the aerodynamic drag analysis around the car body, Jeep to be specific, a RAV4 Jeep, to calculate the force acting on the car body and to also calculate the coefficient of drag. So to start with, we're going to move over to our geometry. The geometry I'll be using, I use the 3D solid modeling software, so I'm going to import it into our design modeler on Ansys. So file, let's import external geometry. Okay, we're going to click on generate. So this is finished generating. I'm going to change my units to millimeter because I'm afraid to work millimeter than meter. Then after this, we are going to create an enclosure around the car body. There are various ways of creating an environment in which your fluid is going to flow. You could decide to use a box, but me, I prefer to use an enclosure. Okay, so another thing is, when designing your car, you should try to take advantage of symmetry, which I'll show you around as I'm filling in my data. Right here, my symmetry is along my X, Y, and my Z plane, because you have to make sure that your tires are touching the road. So number of planes, we make it 2. So the first one is going to be my XY plane, to divide the car body into 2, that is into half, to make sure that simulation is faster. Apply. And the next one is along our ZX plane. So I'm going to input my data. I'm going to make sure my box is 10,000 millimeter in the positive X direction, in the positive Y 3000, positive Z 2000, and negative X 4000. Okay, the remaining negative Y and negative Z doesn't matter because of our symmetry plane. So we're just going to click generate. So we've taken advantage of our symmetry along the XY to divide the car body into halves, then also along our ZX to make sure that our tire is touching the road. The next thing we're going to do is to properly name our environment. This is this supposed to be fluid, is correct here. We're just going to change the name to fluid. Okay, and this is our solid, which is our carbon, which is correct. So the next thing we're going to do is to separate these two entities using Boolean. So instead of unite, we're going to have subtract. So our target body here is going to be our fluid environment, and our two body here is going to be our solid. So apply. So we're going to click on generate. Okay, so that is that. So we're going to move over to meshing. So under mesh, we're going to do our name selection under meshing, and also to create our meshing. But the meshing I'm going to be doing is just a basic meshing. This is just for tutorial purposes. I'm not going to do anything complex. So waiting for our meshing to load. Okay, so creating our name selection, I'm going to pick these surfaces and name them opening. The reason why I'm naming them opening, because these are the surfaces in which our fluid is allowed to flow out. So I'm going to name here our inlet. this place, symmetry road, or road symmetry, anyone, vice versa. And name this one symmetry. Okay. So the next thing we're going to do is to create our meshing. These two fine. High. Okay. And number of cells across gap, make this one 5. Okay, so maximum phase, I'm going to make this one 0.15, and I'm going to make this one maximum size 0.3. And under inflation, change it to program control. So that's all. So we could click on generate mesh. So our mesh is generating, so I'm going to pause the video until our mesh has finished generating. Okay, so our mesh has been generated, so we're going to update, and after updating we're going to move over to CFX to set up our solution. Okay. So CFX is loading. So CFX has loaded. So we're going to set up our default domain. Our fluid we're using is here at ambient temperature, that is 25 degrees C. We're going to leave all the input here okay, as it is. Now under heat transfer we're going to turn off our heat transfer and set it to none, because we're not looking at energy transfer. What we're just going to look at is the fluid flow. Then change our K epsilon to K omega. The reason we're using K omega, it solves better the effect of turbulence due to separation and wake, which we're going to see when analyzing our aerodynamics. So click OK. Then we're going to input our boundaries. So the first one we're going to input is our inlet, which is our velocity inlet. We're going to be using 40 miles per hour. Okay. So the next one is going to be our symmetry underscore road. So this one is symmetry. Click OK. And the next one is our symmetry along the XY plane. Okay. And the last boundary, our opening. Okay, we're going to be using 0 Pascal as the operating pressure. The next thing we're going to do is to input our server control. We're going to be using 500 iterations just for this tutorial purpose. You could increase the number of iterations. I'm going to use 10 as our timescale factor. So you could